Hello, class. The last time we met, we talked about filtration. So today we'll be looking at crystallization. You'll recall that we said filtration is a separation technique that is used to separate insoluble solid in a liquid mixture. Okay, we'll give examples such as sand in water or mud in water, so powder, flour in water, talc in water, and things like starch powder in water. All these can be separated using filtration method. And I also told you that what if you now have a soluble solid in liquid? You cannot use filtration for that because the whole solution will pass through the filter paper, okay, together with the dissolved solutes. Okay, a good example of this kind of problem is having your sugar in water or your common salt in water. When you try to filter that, they will pass through the filter paper. So what you will get as your filtrate will be both the salt and the water, or the sugar and the water. You won't have any residue in that process. Okay, so that is where crystallization comes in. Okay, crystallization is a separation technique that is used to separate. Okay, emphasis on dissolved. Okay, so dissolved solutes in liquid. Okay, in liquid, or you can say soluble solutes in a solvent. Okay, so this kind of mixture can be separated using either crystallization or evaporation. Okay, there is a slight difference between when to use crystallization or when to use evaporation. Okay, the difference is at when you have a solute that is sensitive to high temperature, you use crystallization. But when you have a solute that can withstand high temperature, excessive heating, you can use evaporation. Okay, so you should know when to use which, but both of them are applicable in recovering soluble solids from a liquid mixture. Okay, so how do we carry out crystallization? How is this process carried out? A good example of salt we're using for this mixture is copper 2 sulfate. It's a blue solution. Okay, how can we recover the crystals of copper 2 sulfate from the solution or the mixture? All we need to do is first, we'll boil the mixture. Okay, keep on boiling so that we'll boil off some of the water in the solution until we notice the solution is saturated. The word saturated, you will recall from the previous video, I explained what saturation meant. Okay, it means it means a solution, okay, that can no longer take on a solute, that can no longer dissolve a solute. Okay, and in that solution, you will see the presence of undissolved solutes in that solution. So when you hit this solution and you begin to see this undissolved solutes, okay, appearing like something like this, you can see tiny crystals forming here, okay, in this diagram. Okay, At that point, you stop heating, you turn off the stove or the gas, and then you allow the solution in the beaker to cool. As the solution cools further, you see more crystals forming in the process. Okay? If you want to facilitate or hasten this process, you can do what we call seeding by adding a little pinch of that same salt into the solution to make it form faster. Okay? You get your crystals out, you filter out the crystal, wash it with cold distilled water, and then dry the crystals. Okay, that is how you can recover a soluble solute from a liquid. Okay, so it's that simple. So I want you to now look at these questions. You see, there is a mixture of sand and salt water. Okay, how do you separate this mixture so that you get your sand, you get your salt, and you get your water? Okay, okay, separated from this mixture. I want you to give it a try. When we meet again, I want you to show me what you did. But mind you, the solution to this problem is just the two techniques that we've discussed so far, filtration and crystallization. But the order in which you are going to carry out this process is what I'm interested in. So I want you to tell me which process you carry out first and why. Okay. So when we meet next time, I'll be expecting you to turn in your assignment. At this juncture, I would like to say bye till we meet again.